Hi everyone. In this video, I'm going to go over how to find the distance between 2 points. In this example, I want to find the distance between the points 1, 5 and 4, 9. I'm going to start by plotting these points on this graph. So I'm going to plot the point 1, 5 and 4, 9. And I'm going to draw a line connecting these 2 points. Now, to find the distance between these 2 points, I need to find the length of this line segment. And how can I find the length of this line segment? So, say I drew a triangle connecting these 2 points. A right triangle connecting these 2 points, like this. Then you'll notice I can use the Pythagorean theorem to find this missing side. Because this side of the triangle, well, I know it's 3 units, right? 1, 2, 3. And this side of the triangle is 1, 2, 3, 4 units. So I can use the Pythagorean theorem here to find the missing side, the hypotenuse C. So let's go ahead and do that. Let's use the Pythagorean theorem. So the Pythagorean theorem tells us hypotenuse squared is equal to this side squared plus this side squared. Okay, and I'm just going to plug this in, right? I'm going to plug in 3 in for A, and I'm going to plug 4 in for B into my Pythagorean theorem here, into my formula. So we're going to get C squared is equal to 3 squared plus 4 squared. 3 squared, that's the same thing as 9. 4 squared is just 16. So I have C squared is equal to 9 plus 16. 9 plus 16 is equal to 25. And to get C by itself, I need to take the square root. The square root of 25 is 5. So that means the distance between these 2 points, the distance between 1, 5 and 4, 9 is just 5. So in summary, to find the distance between 2 points, we can use the Pythagorean theorem. And now let's imagine I had any 2 points, right? I had any 2 points, and I wanted to find the distance between them. So I'm going to label these 2 points as x1, y1 and x2, y2. Let's use the Pythagorean theorem to find the distance between the 2 points and find a general formula we can use to find the distance between 2 points. So I'm going to start by drawing a triangle connecting these 2 points, just like I did before. Now, the Pythagorean theorem tells us that hypotenuse squared is equal to the other 2 sides squared. If you add up this side squared plus this side squared. Now, this side, this is the change in x. This is how much x changes. And this side here represents how much y, our y values, change. So we can represent A, in our formula, we can represent A as a change in x. So x2 minus x1, this represents the change in x. And b we can represent as a change in y. So y2 minus y1 gives us the change in y. C, that's the distance, right? C is the distance between these 2 points. So I can label this as, I'll just label this the distance between the 2 points with the letter D. Now, the distance here is squared. If I just want the distance by itself, I can take the square root of this. So that'll give me the formula. Distance is equal to the square root of the change in x squared plus the change in y squared. And this is a general formula I can use to find the distance between 2 points. In this example, I want to find the distance between the points 2, -3 and 6, 7. So I'll remember, I can label these points as x1, y1 and x2, y2. And now I can just use the formula we just learned, right? D is equal to the square root of the change in x squared plus the change in y squared. Let's plug everything in. My 2x values are 6 and 2. So the change in x is going to be 6 minus 2. I can subtract these two values. So I'm going to subtract 6 minus 2. Then I'm going to take the change in y squared. So 7 minus -3. Again, all I'm doing is I'm plugging my points into my distance formula. I'm just plugging them in to find the distance. Now we need to simplify what's inside the brackets. So 6 minus 2, that's just 4. 7 minus -3. Well, a negative times a negative is a positive, right? So this is the same thing as saying 7 plus 3. And 7 plus 3 is just 10. All right. 4 squared. 4 squared is just 16. And 10 squared is 100. 16 plus 10, that gives me 116. And now we just need to take the square root of 116, and that will tell me the distance between the 2 points. The square root of 116 is approximately 10.8. So the distance between these 2 points is approximately 10.8. Let's do one more example here. So now I want to find the distance between -3, 5 and -8, -2. So I'm going to start by doing the exact same thing. I'm just going to label my points. So I have x1, y1 and x2, y2. And now I'm just going to plug it into my distance formula, just like I did here. Okay, so let's plug in these points into my distance formula. Okay, So the change in x, x2 minus x1, that's just negative 8 minus negative 3. All squared. The change in y, that's negative 2 minus 5. Squared. Okay, we're going to start with what's inside the brackets first. So, negative 8 minus negative 3. Again, if you have a negative times a negative, that makes a positive. So really what we're finding is negative 8 plus 3. And negative 8 plus 3 is just negative 5. Here we have negative 2 minus 5. And negative 2 minus 5 is negative 7. Negative 5 squared. Negative 5 times negative 5 is 25. Negative 7 squared. Negative 7 times negative 7 is 49. 25 plus 49 is 74. So to get the distance between the 2 points, I just need to take the square root. And if you plug this into your calculator, you'll see the answer is approximately 8.6. And so this distance formula I can use to find the distance between 2 points.